Hi, everyone. Welcome to Cloud Native Live today, where we dive into the code behind Cloud Native. I'm Taylor Thomas, and I am an engineering director at Cosmonic. Every week, we bring a new set of presenters to showcase how to work with different cloud native technologies. They will build things, they'll break things, and they'll answer your questions. Is the goal of this. So we're going today. We have three people here who work on the Kyverno project to talk to us about everything that they're doing. So this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, it boils down to be respectful of everyone and all your fellow presenters and participants. So, with that all said, let's hand it over to Charles Edouard, Mariam, and Vishal from Kyverno.
Hi, folks.
Hi,
Hi everyone.
Hi, everyone. So I'm Charles Edouard. I joined Nirmata with building Kyverno and open source Kyverno and gave Kyverno to the CNCF, I think almost 2 years ago now. So I'm working exclusively on Kyverno. And yeah, I dropped the mic to Vishal or Mariam.
Yeah, so I think I should go ahead now. So I'm Vishal and I'm a student. I'm a final year student studying computer science, and I have been working on Kyverno for the last 1 year. And it has been a really amazing journey. And yeah, we have worked on a lot of new things for the last couple of months, and I'm really excited to share everything with you. I hope it's a wonderful experience for everyone.
So I am Mariam. I'm working as a software engineer at Nirmata, and I am a Kyverno maintainer. So I am working and I'm working focusedly on Kyverno. I was a previous LFX mentee that working on validating admission policies and bring all the features that support to Kyverno. Yeah, that's it.
Thanks for the interest, everyone. I believe, Vishal, you were going to kick things off with giving a little bit of an overview on Kyverno and everything that's going on. So take it away.
Yeah. So it's been quite some time since we had a release in Kyverno. It's been like 3 months, and during the last few months, we have been working on a lot of things, right? Like we have a couple of new projects and a couple of new additions that we would like to share. So in this session, what we will be doing is that me, Mariam, and Shahadwad, we will be giving you a sneak peek on what's to come, as well as we'll be giving you an overview on what Kyverno is, right? So I think by the end of the session, everyone will have a better idea on Kyverno and what they can expect from us in the next couple of months, right? So everything we'll be discussing today is already out as an alpha release. So if you like anything and you want to try something out, you can just go ahead to its repo and try to use it. And if you have any questions or any suggestion, you can reach out to us via the Kubernetes Slack channel, and we will love to hear from you. Right? Perfect. So before we get started and talk about what's new, let's talk about Kyverno, right? So I think the right place to start for that would be, let's talk about Kubernetes and security in general, right? So let's to kick things off, let's start with a take, which is so Kubernetes is a very good project, which is good at several things, but it does not do security well by default, right? Your security, if you're using Kubernetes, it's your problem. So just let me just give you some time to take that, let that sink in. Um, yep. So when I say that, what I mean is that, yeah, I know that Kubernetes has stuffs like RBAC, and it has other tools that can help you improve the security of your cluster. But the problem there is that it just doesn't give you finer control. It doesn't give you as much control as you would need to enforce security well in your cluster, because every customer, every product, everyone has a different requirement, and they need tools that are tailored to their need, so that they can enforce security and do the right thing, right? And it's not even just about security, right? So let's say you don't care much about security because it's an internal cluster. Even in that case, The problem is that Kubernetes is a very complex system, and it has a lot of features in it, and it is really easy to, mess up, just fall into those little pitfalls that you did not know about. And you really need something that will help you, you know, as a guardrail to protect you against these mistakes, right? And that's where you will need something like a policy engine to protect you from these, just so that a place where you can just enforce policies and um, I will have things set up properly so that you don't make any mistakes like that. Um, so let's talk about policy engine, and hope I convinced you enough to pick up a policy engine. So now that you want one, what can you pick? So let me share my screen. It should be, yeah. So we at Kyverno, we basically have a policy engine called Kyverno. It is a CNCF incubating project, and basically it is a general purpose policy engine which was built and designed for Kubernetes. So if anyone here who has used Kyverno before, they know us as a um, general admission controller, which can be used for Kubernetes. But now we have branched out of Kubernetes and we work on different things like general payloads as well, which you will learn more about in the other part of this presentation. But now, okay, so Kyverno is a general purpose engine, and it is rapidly growing, and we are one of the most popular policy engine for Kubernetes. We allow you to basically have different rules like validation, mutation of your resource, as well as generating new resource and cleanup and all of that stuff. And we also do not require you to learn any new programming language, right? So it is very easy to get started with. You don't need to hire a new person or just learn something beyond what you already know to get started, which is something that is very desirable, because the last thing you want is something that adds more complexity to the system, right? And besides that, we also have a very wide range of policies. And yep, I think we have very wide range of policy that we have created over the last few years, which covers almost all the scenarios like multi-tenancy and pod security, like supply chain security, all of that. So when you just want to get started, you don't even have to write policy. You can just pick the things that you want from here and just start using them, right? So that's Kyverno. That's Kyverno and supply chain security. And now let's talk about important concept here, which would be how do you write a policy in Kyverno, right? So let's go into documentation and writing policies. So where is it? Valid policies. Let's just look at a policy and how a policy is structured and how it looks like. So what you see here on my screen is a standard Kyverno cluster policy. Here you see there is a name and a specification. You know what? I think there is a better resource here for that. I think it would be selecting resource somewhere. Mm, mm, mm. Applying policies and rules. Yeah, perfect. So you have a policy, and every policy can have one or more rules in them, and they have a match exclude block, right? So what a match exclude block is that it allows you to specify what this rule targets. So maybe you want to apply a rule to just a pod or a deployment, or anything that you want, something that has a specific label or in a namespace. And once you have specified that, now you have four blocks, four different type of policies that you can have, like validate, mutate, generate, verify images. That will help you specify what this rule does, right? So you can either validate the resource, validate the current request you have, or let's say you have a mutate resource as well, or maybe a generate or a verify image to verify signatures. You can do all of that using Kyverno. To see examples, you can go to the policy repo. And okay, so this is how a policy looks like. And let's talk about how would you even go about, how would Kyverno go about applying these policies for you, right? So let's just look at the life cycle of how things happen. So let's say you have just created a new admission request and you're trying to create a pod. So what happens there is that you are sending an API request to the Kubernetes API server. And that API server exposes two different webhooks. So we have a mutating admission webhook and validating admission webhook. And we get callbacks from those webhook, and those callbacks are then intercepted by Kyverno. So you send a request. In the mutating stage, we get the resource, we apply your mutating policies. Let's say you have a policy that adds labels to things. So Kyverno will get that policy, get that request, look at the policies, and then apply that policy to your resource, and then send it for schema validation. Once that is done, and if that's successful, then we move on to validating admission. So this is the place where we apply your validation policies, and now we validate the resource just to make sure that you have the, let's say you have the right tags, you have the right digest, and your pod does not your pod does comply with all the rules that you set up. And once that is done, if that's successful, we store it in etcd, right? So what happens if the policy fails, right? So let's just go into reporting. So let's say you have applied a policy, you have a resource. What would happen if, let's say, the policy fails? So there are two scenarios here. Let's say you have set your policy to enforce, right? And in that case, what will happen is that you create a policy, you create a request, and there is a policy that it does not comply with. It will just not let you create the resource, right? You will try to create the resource, it will just block it. You won't be able to do it. But there are some cases where you might want to create a resource because you know that that's not the right thing to do in most circumstances, but there's this exception where you want to do it. For that case, we have an audit type, right? So we have a policy of type audit, and what that does is that whenever you create a resource that fails, it's just going to tell you that, okay, I don't think you should be doing that, but I'm not the one calling shots around here. You can do whatever you want, but just letting you know you should not be doing it, and you are violating some of the policies. So how it will do that is that it will create this thing called a policy report, right? And these policy reports are actually Kubernetes custom resources, which are also stored in your etcd cluster, right? Um, so these policy reports are basically contains the results of all the policies that have been applied to a resource. So it has like multiple results for multiple policies, and in the end, it aggregates all of them and tells you which one of them pass and which one of them fail. Right. So these are stored in your etcd cluster, right? So that's that. And now let's talk about that. This is what Kyverno does, and this is the basic structure of Kyverno. Let's talk about the things that we have worked on in Kyverno. So there's one thing related to this reporting. That's why I was focusing on this one. So let's say you have been using Kyverno for a very long time, and now I would say now you have, grown your cluster, and now your cluster has like 1,000 pods in it, and you suddenly notice that all of a sudden your, what is it, your request to API calls are taking way too long, right? But that might be happening because um, your cluster has so many resources that API server cannot keep up with all of them, right? You're just sending too many requests to the API server, and it just takes time to process each one of them, and that's why every request takes so long to process. That's not even the main problem. There's one more problem that you might run into in the future, and that is with your etcd, which is the storage that you use. Etcd has a theoretical limit of 8 gigabytes, and the problem with that is that if you have a very large cluster, you might just hit that 8 gigabyte limit. Did someone say something? Sorry.
No, it's just a little mic issue. You're okay. Keep going.
Okay, great. So I think I should change my screen. That would be great. Uh, 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 uh. Yeah. So there's another issue that you might run into, and we have recognized that. So that is with your etcd, and the etcd has a theoretical limit of 8 gigabytes, which can easily be crossed if you have a very large cluster with a lot of resources. You can add another etcd instance, but then again you have a limit of 16 gigs instead of 8, which is still a limit. So how can you fix that, right? You have a couple of problems, that is performance, and the other one is the size limit. And to fix that, we have created a new project which is called Report Server. So what this is the this document that I'm showing is the KDP, is the design document that covers it. So a report server works similar to the policy server, if you're aware, and I think there is a diagram somewhere. Perfect. So what the report server does is that it takes your API calls that you are making to create and update reports, and instead of sending it to the standard API server, which is, this is the standard route, basically the API server, and this is the standard which every other resource will follow. Instead of doing that, it will send it to something called an extension API server. And what that does is that now you have now whenever you try to create a policy report, it will send it to the extension API server, and that will, instead of storing it in etcd, it will store it in another database which does not have any limit, and in our case it's a relational database. So now this solves two problems for you. Now the API server has more headroom, so it can process more requests and your requests will be faster. And now your etcd won't hit the limit of 8 gigabytes because the policy reports are stored in a different place. And there's a very good reason of why we can do this for policy reports and maybe even Kubernetes events. That is because those things do not store historic data. They are just created and deleted all the time. And even if someone accidentally deletes them, even if you lose them, they will still again get created. Those things don't need the guarantees that are provided by etcd. So you can easily store them in some other place which is not etcd. So that's how we do it. And we have a project which, if I can, yep. So this is the project repo. It's called report service, and the Kyverno is public. You can go ahead and take a look at that. And we have documentation covering that, and we have multiple ways to install it as well. And I will be showing you a demo right now on how we can do that. So you don't have to do much if you want to install the report server. All you have to do is just take the install manifest of the report server and then just apply it to your cluster. And once you have done that, then you can just start working with the report server instead of the standard API server. Let me just show a quick demo on that. Let me just stop sharing my screen and just make sure that.
For those interested, I'm dropping the link down in the live stream, so you should be able to see that if you want to check out the report server.
Yep, thanks. Great.
And by the way, it was something a couple of users have been asking for a long time.
Yeah, it's always really great when you get to deliver those things. So for those who've been using it, this is something obviously, like if you've been using Kyverno before, you might have run into this need already. So thanks for calling that out.
Mm-hmm. All right. So here
Can you
I have
increase the size of your terminal font, Vishal, just so people can read a little bit better?
Is that better?
You do it like 2 or 3 more times.
Okay, just give me 1 second.
We all like to pretend we can read the tiny font, but we all eventually have to go increase our font size anyway. There we go. That'll be perfect.
Okay. Okay, that's nice. And let me just resize that. Okay, so here I have a standard cluster. Actually, I already have it pre-installed. I forgot to uninstall it before the event, but I'll just pretend that I did not install it. So kubectl apply. So what you have to do is just apply this manifest, and it will just create a couple of things. Unfortunately, I forgot to uninstall things, so you have to deal with this. Yeah. So what it does is that it creates a couple of things for you. The most important things are it creates some API services. So we have the API service for nice. Yeah. So we have the API service for the policy working group as well as the reports working group, as the Kyverno reports working group. So these store the ephemeral reports which we use to aggregate, and these are the upstream policy reports, which is managed by the policy report SIG. So those are two things, and what they do is that, let me just quickly get API services. So you see that there's every other API service, and then there are, wow, very cool. Then there are these two, report server, as well as, let me just do that again. It's been acting up lately. So it'll get API services. Perfect. Yeah. So then there is like these two, the reports API service, and they don't send to local. So what local means is that your reports, they are going into etcd and through the local API service. And when you have it set to something else, which in this case is a report server, what it tells Kubernetes is that instead of processing that request in your local API server, what you should do is you should just send it to my service, which in this case is report server, the name of the service, and the namespace, which is also report server. And then that server will then process the request and do whatever it wants to wherever it wants. And that's how that will work, right? So now let me just try to create something. Let me just try to create a test policy report, right? So I think I should just do test /test policy report. So basically I just have a standard policy report here, which contains everything. And let me just try to apply this file /test policy. Oh, nice. So what is that? Whew, no kind policy report. I think I might have already created it. I do get policy reports if I get it. Oh, I already have one which was created a long time ago. Let me just delete it. Delete pure test.
And for the audience, this is the telltale sign that this is not a canned demo. This is live.
Yeah.
Great job on this, Isha.
Yeah. So finally, I got my PC to work. It's finally listening to me. Okay. So I deleted the old one and I created a new one. You can see that kubectl get policy reports. I just created a new policy report. And if I just fetch it, kubectl test YAML, right? So it's the same policy report that was there and it got created right now, and that's that. So it might look like the exact same thing is happening previously, but like if you did not have this cluster, but there's one difference, and that is there is a new pod in the report server namespace, which is a Postgres database. And if I exec that pod and just provided the password, perfect. And this is the Postgres database where everything is stored instead of etcd. So let me just reports db, and I'm connected to the right db. And if I just query the database, so this pod, which is a Postgres instance, it has a couple of tables in it. So 2 for the upstream policy reports and 2 for our ephemeral reports, which we use in Kyverno for other things. And if we try to get report that we just created from which is the policy reports, where name equal to test, right? So you can see that this was the policy report that was just created. Its name is test, and it's the default namespace. And so whenever you query that, query the database, query the API server to get policy reports, API server is then going to the service, which is connected to this Postgres instance, and it is fetching those reports from here. So the advantages that having them in a Postgres instance does, the advantages of having them in a Postgres instance of etcd is that now you do not have a limit for that. And actually you don't even need the guarantees that a transactional database like etcd needs, because even if some data get lost, Kyverno will eventually create those policy reports for you anyways, right? Because it is just the data that gets updated all the time, so you don't have to worry about those things as well. So all you have to do, even if you are running on a cluster that already has Kyverno installed, you just have to apply the YAML file, and all the existing policy reports that you have will again get created for you, and you don't have to worry about anything. So that's how policy the report server works, and you can try it out on your local cluster. The information for that is already present in all of that. Installation instruction is, wait a second, it is, yeah, it is present in the report server documentation. You can follow the guide. We have a migration guide as well as everything you will need for configuring a database and everything. All of the information is present here, and yeah, go ahead and try it out. If you have any questions or query, you can reach out to us via Slack. And yeah, I think I've taken quite a lot of time in covering all of this, and we should now, I might have bored you a lot. We should start covering other things as well. So after this, let's discuss something about VAP, which is Validating Admission Policies. And I will like to invite Mariam to go ahead and cover this now. So, Mariam.
Okay. So we are gonna talk about Kubernetes validating admission policies and how Kyverno can be used to manage and generate these policies. So first of all, let me share my screen. Okay. So yeah, is it clear now?
Yes, it is. You're good.
Okay. So first of all, Kubernetes validating admission policies are used to declare some validation checks that will be evaluated against the incoming resources. So if these checks are evaluated to true, then the API server will allow the creation of such resources. Otherwise, they will be blocked. And these validation checks are written in cell expressions, and they are usually evaluated directly in the API server, which means that these validating admission policies don't require an admission webhook, and therefore it reduces, of course, the complexity of implementing and maintaining the admission controllers, and it also reduces the latency that results from the round trip between the API server and, of course, the admission webhook server. So it's pretty straightforward, and it doesn't require any third-party product to execute it. So let's see how to write a validating admission policy. First of all, we write a policy definition, and of course we write a binding for this definition. So let's start with the policy definition. The validating admission policy is used to, as I said before, to declare validation checks, and they are usually written in cell expressions. And the second thing is that the policy definition must declare which resources this policy are gonna apply to. And for example, this case, the validating admission policy will match deployments, and it makes sure that the deployment replica is less than or equal 5. And the second important resource that needs to be created along with the policy definition is the policy binding. As you see here, the validating admission policy binding is used to declare the validation actions that the API server will take in case the resource violates the policy. Of course, there is other values for validation actions like warn and audit, and of course in these cases the API server will not block the creation of the resource in case it does violate the policy. For the sake of this example, the validation action is set to deny, and the most important thing about the validating admission policy binding is that it provides scoping to the policy definition. So together with the binding and the policy, it will be applied to resources. For the sake of this example, both will be applied to deployments, but not all deployments. It will be only applied to deployments whose namespace labels set to environment as a key with test as a value. So this what does it mean by that binding provides scoping to the policy definition, and there are alternative options, like you can use the object selector, and there are many more. With that said, validating admission policy is used to define policies, and and of course apply those policies to resources, but they lack many useful tools in providing full policy management experience to users. And of course, this is where Kyverno comes in. So Kyverno is a batteries included experience in managing, validating, and mission policies, and one of the most useful tools for. Okay, you see my screen now?
Yeah, we can still see everything. You're good.
Yeah, okay. So one of the most important tools that Kyverno provides is the CLI. So Kyverno CLI is extended to apply and test validating admission policies locally or against clusters, and this allow the users to simulate the policy enforcement simulate the policy enforcement without altering the cluster state, without doing any changes to the cluster. And of course, this allows the policy authors to make adjustments whatever they want in policies, and to make sure that these policies will align the desired outcome before deploying these policies in the cluster. And of course, users can apply these policies to resources in CI/CD pipelines, and there are many more use cases that you can use the CLI in. I prepared a quick demo on how to use the CLI. Okay, so first of all, we have this validating admission policy, where it matches deployments, and it makes sure that the deployment replica is less than or equal to. And we have, of course, the validating admission policy binding with the validation action set to deny. And the binding says that it will not apply deployments in all namespaces, but the policy will be applied only to deployments whose namespace labels is set to environment as a key, with the values of either staging or production. So this policy will be applied to only those deployments who exist in namespace with such a label. And of course, we have, some deployments to test this policy against. So we have 6 deployments. The first 2 deployments are deployed in the testing namespace. One of them has a replica of 4, and the other has a replica of 2. The second 2 deployments are deployed in the staging namespace. One of them has a replica of 4, and the other has a replica of 2. And as expected, the first 2 deployments are deployed in the testing namespace, so we expect that the policy will not be applied to them at all. And the second 2 deployments will be, they are matching the conditions, or they are in the matching criteria for the policy, and the policy will be applied to both. One of them will fail, and the other will pass. And the third one, finally, the last 2 deployments are deployed in the production namespace, and again, one with 4 replica and the other with 2 replica. And again, as expected, the policy will be applied to these resources as well. So As I said before, we can test policies locally without even communicating with the cluster. And for the sake of this example, we are providing the values manifest where we specify which namespaces we have, and these namespaces has which labels. So here we are specifying that we have a namespace called staging with this label, and the same for production and testing. The last thing is, the main resource for testing policies against resources is writing a Kyverno test YAML file where we specify the policy and we specify all the 6 deployments. Each file contains 2, and then we are specifying the expected result. So here we are saying that the expected result of applying this policy on these resources will be a failure. The same for the other two, since staging and production has a replica of 2, then we expecting that the result will be a pass, and same here. So, and of course, we are passing the values manifest file so that the CLI can know which namespaces we have and which labels they have. Okay, so let's run this command. Here we are using the Kyverno test command, and as you see here, the result is for all of them is pass, because actually the Kyverno CLI test command compares the expected result that we had written in this manifest file against the actual result of applying the policy to the resource. And if they are equal, then the overall result that appears to the user is pass. And as you see here, the testing deployment 1 and 2 has a result of pass, and they are excluded because we expect that the result will be skipped, because policies will not be applied to deployments that exist in the testing namespace. So this was a quick demo about Kyverno CLI. There is many more to discover regarding this part. Another important thing is the reporting system. So Kyverno provides a reporting system that is used to generate policy reports as a result of applying, validating, and mission policies to resources. And these policy reports actually provide valuable information and insights about the compliance and the status of these policies in the cluster. And actually, the users can, analyze the reports and see the policy validation and see, which policy, which resource violates the policy, and according to that, they can take appropriate actions and rectify these resources. So it's really important for having or generating such reports for validating emission policies. This reporting system actually exists for Kyverno policies, and again, it's extended for providing this kind of system for validating emission policies as well. And I prepared a quick demo for this. Okay, so we are using just the same example as before. In the CLI, we have the check deployment replica, and again, it provides scoping to the deployments. They both resources will be applied to deployments in case they have the required namespace labels. And again, we have the same 6 deployments. And okay, I'm gonna try first to create these deployments. Let's check first that we don't have any records. Okay, and let's apply first the deployment. The idea behind applying deployments first is that we want to see that there are actual, policy reports generated as a result of applying the policy to existing resources in the cluster. So we first apply deployments, as you see here. At this point, there is no policy, so all of them will be applied as expected. They will be successfully created, and then we are gonna apply the policy. Okay, and as in the previous example, we are expecting that the deployments whose namespace is testing will not be checked or applied against the policies. So if we try to check if there is policy records in the testing namespace, we will see that there are no policy records generated for these resources because there's no actual policy applied to them. Okay, and we can try to get policy records from the staging namespace. And as you see here, there are two policy records. The first policy record is for the staging deployment 1. Okay. The staging deployment 1, whose replica is 4, so it got a result failure. And the second record is for the staging deployment 2, and again, it has a replica of 2, so we expect that it passes. And this is what the policy records tells us. We can have a quick look on how the policy records look like. So first of all, we have this policy report, and it says that this policy report actually is generated for this deployment, and the result is a failure. This is the result of applying the policy and its binding to, this resource. And the second report is the same. Yeah. We can check if there is some records in the production namespace, and here we have the same not the same, of course, not the same policy records, but again, for each deployment, we have a policy record for that. And since the production deployment 1 has a replica of 4, it got a result of a failure, and we have another deployment that has a replica of 2 that it passes, and it doesn't violate the policy at all, so it gets a pass as a result. Okay, so again, there is a lot more about policy records that needs to be discovered, and there are many cases on how we can generate these records and how we can benefit from the data or the information they are providing us. But feel free to explore it, and if you have any questions related to that, feel free to ask on Slack channel, and we are glad to help. The last thing is about Kyverno policies itself and how Kyverno can generate and manage the full life cycle of validating a mission policy. So first of all, Kyverno policy has a validate.cell subrule. This is a new field that was introduced, and here you can write the cell expressions that you wanna evaluate them against resources. And there are some flags in the admission controller that you can use so that you will have the freedom to either generate validating admission policy from this Kyverno policy, or you can let the Kyverno engine handle the resource validation itself. And in case you chose that there will be a generating validating admission policy for this Kyverno policy, then you will see that there is a field in the status of the Kyverno policy says that it is successfully generated. And you can see that there is, a validating admission policy actually generated, and there is an owner reference that it comes from, or it comes as a result of Kyverno policy. And of course, if you update or delete Kyverno policy itself, you will see that any operation or anything you do in the original Kyverno policy will be directly reflected into the validating admission policies. That's it. I hope this was beneficial for you. And given the importance of policies in Kubernetes, it's really important to have policies that checks and validates other resources like Terraform, Docker files, and many more. And this is how Kyverno JSON works, and it will be introduced by Shalvar.
Thanks, Mariam. So, hi everyone. I'm going to terminate this live stream by presenting two new tools that are gaining popularity and adoption. So, the first tool is Kyverno JSON, and that's something users were asking for quite a long time. And this new tool allows applying sort of Kyverno policies outside the Kubernetes world. So let me share my screen and I can, okay, select a tab. So I need to select a tab. No, I guess I can share the entire screen. Yeah, this one. Okay, and the second tool will be about Chainsaw, which leverages what we did in Kyverno JSON and applies the technology in Kyverno JSON to end-to-end testing for Kubernetes operators and more. So do you see my screen?
If it's visible, it's good to go.
Okay, perfect. So this is the GitHub repository for Kyverno JSON. So basically, Kyverno JSON is Kyverno for any JSON compatible payload. So JSON compatible payloads include Terraform files. So eventually, Terraform files are not written in JSON out of the box, but there are tools to convert those Terraform files or Terraform plans or Terraform resources into JSON payloads, and those JSON payloads can be evaluated against Kyverno JSON policies. The same thing applies to Docker files. We can take a Docker file and we will look at an example how Kyverno JSON policy can validate or reject a Docker file. It can be applied to cloud configurations. It can be used to perform service authorization requests. And we have an LFX mentorship coming to create an Envoy plugin based on Kyverno JSON to allow using Kyverno JSON as an authorization framework. And that's it. So we have all the documentation available here. We have a small policy catalog, but it is expected to grow in the coming weeks or months as Kyverno JSON is more and more adopted by more users. We have good documentation. So basically, Kyverno JSON comes in three forms. You can use it as a Golang library. We have a command line interface. It's the Kyverno JSON tool. And we also have a web application with a REST API. You can send your payloads. The policies are registered in the Kubernetes cluster as CRDs, and then you can create your custom resources for your policies. And that's it. So the next step is to look at how to write policies. It looks like Kyverno policies, but not exactly the same. So the first thing to note is that the API version is json.kyverno.io and not just kyverno.io. So the structure of Kyverno JSON policy is a little bit different. It shares a lot of similarities with Kyverno policies, but there are subtle differences, of course. The kind is validating policy. Then it's like any other Kubernetes objects. You have metadata, you have a name. It's a cluster level resource. So there's no namespace, but you can have labels, annotations, and everything else in metadata. Then you have a spec. The spec is made of rules, and all rules have a name and they validate a couple of things. On top of that, we have the match and exclude statements that we are used to manipulate in Kyverno policies. The only difference is Kyverno policies are used in the Kubernetes world. So it was easy for a Kyverno policy to manipulate a kind or a namespace because those concepts are always present in a Kubernetes cluster. As Kyverno JSON wants to address more than Kubernetes clusters, we needed more flexibility. And basically, what you put in a match and an exclude can be anything. So in this example, the policy is going to validate S3 buckets tags. So we are going to make sure that every S3 big bucket has a team tag, and this team tag has a value. But an S3 bucket doesn't have any kind. It doesn't live in a namespace. It doesn't mean anything for an S3 bucket to talk about a namespace or anything else. But in this case, we know it's an S3 bucket, and an S3 bucket will have a type, and this type will be AWS S3 bucket. So everything you put in a match and in an exclude statement will be evaluated against an incoming resource, and it has to match or not, and it will be accepted or not. And of course, we will support the context entries we are used to find in Kyverno policies, but we don't have and we don't need for each statements, we don't need pattern operators, we don't need anchors or wildcards or things like this, because in Kyverno JSON, everything is every validation or every check is actually an assertion tree. That's something we created just for Kyverno JSON and that we reused later in Chainsaw. So basically, an assertion tree supports complex expressions in the key of the YAML structure. So in this case, we are going to check, for example, this is a pod, because Kyverno JSON can also work with Kubernetes resources. It can do more, but a Kubernetes resource is made of YAML or JSON. So there's no reason why Kyverno JSON could not work with Kubernetes resources. So in this case, it will be a pod, and we are going to check that the spec.service account name equals default is false. So we don't need patterns like not default or greater or equal to default to 3 or 4. So that's really the difference, the real difference with Kyverno policies. We made a syntax that's more flexible than what we had in Kyverno policies, and it allowed us to remove for each patterns. Everything like this are not necessary anymore. So I guess we have only 5 minutes left, so I can make a quick demo. So I talked about Docker files, and I have a quick demo that does just that. I have 2 tests there and the policy. So this policy is going to be evaluated against a Docker file. This is a very simple Docker file, and everyone can see that it's just calling wget with a number of options and an URL. The idea is that we first need to translate this Docker file into a JSON payload. And there are tools that do that perfectly. So you can look that up on Google, and you will find tools that can do that. And then we have the corresponding JSON payload with the stages, with the from statement, the commands. And then we have all the commands that we can find here in our Docker file. Maybe I should, make it bigger. So yes, this is the Docker file, and this is our policy that tries to check that stages, commands that have the name run, and look at the command line of those commands. And if something starts with wget or contains wget with the -- no check certificate flag is present, we expect this to be false. So we don't want any string, any command starting or containing wget and containing this this flag, because it's considered unsecure. And if I run this simple test, so against the first Docker file, which is supposed to break, I have the error detected by Kyverno JSON, and we see that we have an invalid value, true, and we expected false. So that's the expected value, and if we have true, it means that we have this in the Docker file, this flag, and it's true. We have this flag in the Docker file. We have this wget command in the Docker file. And of course, I have the equivalent good test, which is also a wget, but without the forbidden flag. And in this case, if I run this second test, this time it passed, because nothing is breaking the conditions of the policy. So that's it. I see we have only 2 minutes left. Taylor, do you want to? Are there questions or anything else?
Currently, there aren't any questions from the chat, and given the time right now, I think I had a few, but I'd stage those up. So I just want to wrap this up and say thank you to you all. This was there were some really great demos here. Everyone can go check the project out. I believe the website's kyverno.io, correct? And so you can go check out the project there and check out and see what they're up to and all these things that they've been demoing and what you can do and use them for. So thank you so much for coming. We're so thankful for all the effort you guys put into this, and we really hope that everyone enjoyed it. And we'll be having the next live stream in a little bit, and we hope to see you all there. So thank you all for coming, and thank you all once again for presenting this. Thanks, everyone. See you all.
Bye-bye.
Thank you.
Thank you.